All right, so today we're going to move on to probability. Yesterday we just talked about permutations, combinations, basic counting principle, so number of ways you can arrange something. Today we're going to talk about probability, which you hear often as like 1/2 or 50% or 0.5. We're going to stick to fractions typically. So if you could just remember successes over totals, that's the general definition for probability. Experimental probability is what actually happens, and theoretical probability is what should happen. So this is theoretical probability. Okay? So in the first problem it says each letter of the word probable is written on a card. The cards are placed face down and are mixed up. What's the probability that a randomly selected card is a consonant? So probability is success over total. So if you look at all of our letters, we want just consonants. So ones that are consonants are P, R, B, B, and L. So there are 5 consonants, and there are 8 total number of letters. All right, so it would be 5 over 8. Now we could change that to a decimal or a percent, but we're just going to leave it as a fraction. All right, it says a red number cube, this is also known as a die, and a blue number cube, that's another die, so 2 dice, are rolled. If all the numbers are equally likely, what's the probability of each event? Okay, so to get a sum of 6, so if you think about the dice, you've got 1, 2, 3, 4, 5, and 6. Okay, so those are all your possibilities. So to get a sum of 6, you could have 1 and 5, right? You could have 2 and 4. You could also have 3 and 3, right? 3 times 3 plus 3 again. You could also mix these up. So you could have 4 plus 2. You could have 5 plus 1. All right. So the easiest way to think about this is if you have your reference sheet. We're going to look at this chart. Okay. So this shows all the possibilities of having two dice rolled. So we've got 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. So 1, 2, 3, 4, 5. So there's 5 of them, which we've listed here. So you could look at this dice sheet or you could just write them out. So there's 5 successes over, there's 36 total. Right? So if you count up how many different combinations, all this is 36. So it's 5 out of 36. All right, so here it says the difference is 6. So is there a way to, here's our 6 dice. Could we subtract 2 numbers? Difference means to subtract. Right? Could I do, like, even if I did 6 minus 1, right, that would give me 5. So that's not possible. So there are no successes over total of 36 rolls, so that would be 0. Right? So not possible at all. All right, so it says the red cube is greater. All right, so if you look at where would the red cube be greater? Okay, so greater, let's assume that these dark ones, let's assume this color is red and this color is blue. Okay, so this would be greater. Any of those. We could have 6 is bigger than 4. 6 is bigger than anything. 5 is bigger than 3. 5 is bigger than 2. 5 is bigger than 1. All right, so I think these are all the possibilities. These are going to be when they're equal, and then the rest of them are going to be when red is smaller than blue. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 successful ones over 36 total. So that's 15 over 36, but if you reduce that, that's 5 over 12. Okay? All right, flip to the other side, please. All right, so number 3 says 2 integers from 1 through 10 are randomly selected. The same number can be used twice. What's the probability that both numbers are less than 9? All right, so if I have 2 integers from 1 to 10. All right, so I've got my first selection. All my numbers that are less than 9 are 1, 2, 3, 4, 5, 6, 7, or 8. So that would be my 8 successes out of 10 total numbers. All right, so that's the first thing. The second time I select, it says you could use the same number twice. So I could still also pick 1, 2, 3, 4, 5, 6, 7, or 8. So I could again get 8 out of 10. So now you just need to multiply those two results. So if you do that, 8 times 8 is 64. 10 times 10 is 100. And if you reduce that, you get 16 over 25. All right, problem 4. Each student receives a 5-digit locker combination. So first digit, second digit, third digit, fourth digit, and fifth digit. So this is kind of like our general counting principle or basic counting principle from the other day, except we're just going to put fractions in here. So each of these needs to be a probability of success over total. What's the probability of receiving a combination with all odd digits? So let's remind us that the odd numbers are 1, 3, 5, 7, and 9. Out of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Nope, not 10. Just 0 through 9. Okay, so there are 1, 2, 3, 4, 5 out of 10. And it would be the same probability for each number selection. All right, so if I were to multiply all those together, right, I get 5 divided by 10 times 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 5 divided by 10. And I change it to a fraction, and I get 1 over 32. All right, number 5. It says a DJ randomly selects 2 out of 8 ads to play before a show. 2 of the ads are by a local retailer. What's the probability that she will play both of the retailer's ads before the show? All right, so if the first likelihood is 2 out of 8, right? 2 out of 8 are from this local retailer. All right, it says 2 of the ads are from the local retailer. Now, the second time around, if I've already played, let's say there's 8 ads, and I've already played one of them, now that only leaves me 7 of them. Okay, so let's assume that we've already picked one from the local retailer, so it's 1 out of 7. So when you multiply, you get 2 over 56, and if you reduce that, you get 1 over 28. All right, these are all theoretical probability. This is what theoretically should happen. This problem is going to be an experimental probability. So this is what actually happens. Okay, so it says the table shows the results of choosing one card from a deck of cards, recording the suit, and then replacing the cards. So they got 5 hearts, 9 diamonds, 7 clubs, and 5 spades. Find the experimental probability of choosing a diamond. Okay, so how many diamonds were there? There's 9 diamonds. Total is you have to add up what's 5 plus 9 plus 7 plus 5. Okay, so if you add those together, you get 26. Okay, so we have 9 out of 26, and that does not reduce. All right, find the experimental probability of choosing a card that's not a club. So, not a club would be diamonds, spades, and hearts over our total of 26. So that would give us 19 over 26.